Welcome to ESG Decoded, where we navigate the evolving landscape of environmental, social, and governance, ESG. Join me, Amanda Kuhl, and Erika Schiller as we explore the intersection of sustainability, innovation, and ethical leadership.
Hello, everyone, and welcome back to ESG Decoded. My name is Erika Schiller, and I'll be your host today. Joining me is Emily Romano, a senior manager in ClimeCo's nature-based team who leads our project development arm, and David Chen, also a senior manager on ClimeCo's nature-based team looking at early-stage project assessments. Emily just published a blog on ClimeCo's website about mangrove projects, blue carbon, and ecosystem benefits of these projects. So we're really glad to have you today, Emily, to talk to us more about those ecosystem benefits. But we'll start just at a high level. What is blue carbon, Emily, and where is it found?
Sure. Hi, happy to be here. So blue carbon most often refers to the organic carbon that is stored by coastal and marine ecosystems. So that primarily means in mangroves, tidal salt marshes, seagrass meadows, and kelp. But it can also include carbon pools that are stored by oyster reefs or in the shells of other shellfish, marine phytoplankton, and I've even seen definitions that include underwater ocean sediments and the CO2 that's been directly absorbed by ocean water. Our team's focus is mainly on those first three vegetated ecosystems. And those are found primarily along coastlines on all continents except for Antarctica in a few different landscape positions. So mangroves are found near the tropics in the intertidal zone of the coast, where their roots can be inundated for a portion of the day and then alternate to being dry for a portion of the day. Tidal marshes and seagrasses are found at a wider range of latitudes. As you might guess from the name, tidal salt marshes form only where they can be tidally influenced. So that includes along the edges of tidal rivers where water is saline or brackish. And then seagrass beds, oyster reefs, and kelp all need to be completely submerged. So those are found in progressively deeper coastal environments from the very shallow marine. Many seagrasses, for example, are found at about 10 feet of water depth down to oyster reefs around 30 feet and kelp, which can grow between 50 and 100 feet below sea level.
So all these animals, creatures, plants, they all, as they're growing, they absorb carbon. And that's why they're called blue carbon, because they live in and around the ocean.
Yeah, that's right.
And how much carbon is stored by these ecosystems? What makes them so efficient at storing carbon?
Yeah, all three of these store enormous amounts of organic carbon, and in some cases that those stores have been held for hundreds to thousands of years. So the reason for the efficiency is that in these ecosystems, net primary productivity, or the drawdown of CO2 from the atmosphere into biomass, is really efficient, and it happens at a high rate. The other reason is that storage in soils within the waterlogged conditions means that those soils are anaerobic. So when plant material falls, becomes incorporated in the soil, becomes soil organic matter, microbial decomposition is much less efficient at turning that plant material back into CO2. And so the soil organic carbon accumulates and creates really thick mats.
So there's no oxygen there to help those microbes break down the carbon, so they stay
Right,
locked.
exactly. Yeah. And so in the ecosystems as a whole, carbon is mostly stored in the soils for that reason, but it's also stored in above ground and below ground biomass, so leaves, branches, roots, and in dead plant materials that rest on the surface, so leaf litter and dead wood. And you asked how much. So mangroves and tidal salt marshes store between 3 and 5 times as much as terrestrial forests. And seagrasses store about twice as much per acre as terrestrial forests. So these categories take up much smaller amounts of land than terrestrial forests do, but they're just really incredibly efficient.
That's great. So, beyond just carbon, what are the other benefits of these ecosystems?
Oh, there are so many. So for mangroves and tidal marshes, the first thing that comes to mind is the very dense network of live biomass. So for mangroves, it's these thick above ground root networks. For tidal marshes, it's grasses and other types of surface vegetation that stabilize the coast and trap sediment. So this has the effect of preventing coastal erosion, attenuating wave energy, absorbing storm surge. They also improve water quality because they trap eroded soil that is flowing off of the land. They trap nutrients from runoff. They also provide important habitat within regions with extremely high biodiversity, serving as important breeding grounds and nurseries for fish and game species. They serve as food sources for humans, for coastal communities, so crabs, fish, shrimp, clams, etc. And they can attract ecotourism, so bird watching, educational opportunities. And then one last comment is seagrass provides many of the same benefits as mangroves and tidal marshes, but also serves as a habitat corridor between coral reefs and mangroves, oxygenating the ocean water in between. So all three have many different benefits just for coastal geomorphology, biodiversity, and for people.
Yeah, so with climate change bringing bigger storms, the having a natural blue carbon ecosystem of mangroves, seagrass, et cetera, increases the resiliency of that coastline and filters the water so that the ocean ends up being cleaner and less disturbed by runoff from the land around it.
Yeah, I think that these ecosystems both protect the ocean from the negative impacts that the land would otherwise have on it, and the other way around. They protect the land from the negative impacts of a storm hitting the coastline. So it's really, really important that these ecosystems be intact in both directions there.
Mm-hmm. And so we know that these ecosystems can be destroyed, cut down. You know, people will damage it because they want access to the beach and they want it to be a swimming area or whatever, build a wharf. So, you know, we need also methodologies and incentives to restore or protect these ecosystems. So, you know, can you share a bit about what methodologies exist and activities around protecting and restoring blue carbon ecosystems?
Sure. Yeah. The methodologies and approaches tend to divide into two camps. So the first is avoiding emissions. Maybe that's avoiding conversion, whether that's planned conversion or unplanned. And so Vera's Red Plus methodology, or VM7, is a good example of this approach. It applies to mangroves, tidal wetlands, seagrass, other types of forested ecosystems as well. Gold Standard has a methodology for collecting seaweed to avoid emissions from decomposition. So that avoided emissions pathway is one approach. The other is the restoration of degraded systems. And so one methodology we're using is Vera's VM33, methodology for tidal wetland and seagrass restoration. That one targets specific activities that include managing hydrology and sediment. So, for example, a project could re-wet drained organic soils, or it can manage salinity or water quality by restoring tidal flow to an area that's been cut off from the impact of tides. It could also include managing native plant communities. So we think of revegetation, replanting of woody vegetation. That's where we are replanting mangroves in Indonesia. We have a coastal replanting project in Louisiana as well. So that's the Vera methodology. There's also a gold standard methodology for, it's called sustainable management of mangroves. We have not used that one yet, but gold standard is looking into developing other methodologies as well. But for now, yeah, I think those are the major ones. I know Vera's trying to develop a few for seaweed and kelp aquaculture as well.
And then these methodologies are a way to quantify a carbon credit and create a carbon credit, which is then a way to fund these restoration activities or protection activities.
Yeah, exactly. And I think it's very important to ClimeCo to try to fund not only the carbon elements of those projects, but also to consult with local communities and try to put some of that money back into the community so that we're creating other benefits wherever possible for social benefits and for biodiversity in those areas.
Yeah, and you would also think that if a coastal community is involved in protecting or restoring this, it's going to have more buy-in and durability because it's protected in a more social way.
Yeah, a lot of the reasons that these ecosystems are damaged in the first place involve people, and if people's needs are not met, then no project developer can go in and expect that that the people would leave an ecosystem in its natural state if they don't have what they need. So that's often the first step.
Yeah, can you talk about other challenges associated with effective restoration of these ecosystems?
Yeah, so unfortunately, a number of blue carbon restoration projects have failed around the world because they did not adequately consider some of the geomorphology considerations or the biology considerations of where species want to be restored. So, for example, mangroves can be planted in the wrong location, or the incorrect species can be chosen for the wave energy, the salinity conditions, the tidal times, or the shape of the coastline. The hydrology might not be quite right. So that, I would say, can be a challenge for some. But once the site is well understood, I think that the restoration activities go pretty smoothly, or they could go smoothly. A major challenge is when the primary drivers of ecosystem degradation are related to coastal development, as you mentioned. Those are really difficult to reverse. So we talked about making sure human needs are met, but if a developer has built homes or different types of infrastructure, that's almost impossible to reverse because people live there now. So
Mm-hmm.
in some cases where land was converted along the coast for agricultural uses, as is unfortunately often the case for unsustainable agriculture or aquaculture practices in Southeast Asia, for example, this is often the case for unsustainable palm oil or shrimp ponds, fish ponds. Those are used in the short term and then they're abandoned. They often become unproductive.
Mm-hmm.
And so that land can be restored. But the challenge is that then the group that cleared those areas is probably moving on to the next parcel of mangroves. So
Yeah, and I'd say also closer to home in the US, we have mangroves in Mexico, in Florida, and those areas have kind of similar challenges, right?
yeah, that's true. And of course, anywhere in the world, these ecosystems will have to face the consequences of a warmer world. So that means challenges for species that are part of the food webs in these ecosystems. It means ocean acidification and sea level rise, intensification of storms. So, by and large, coastal environments are pretty tolerant of dynamic conditions, but all systems have limits.
Mm-hmm. Super interesting. So thank you, Emily, for sharing a bit about kind of what is blue carbon, what do we mean by that, where do the credits come, what activities qualify to generate carbon credits in this blue carbon ecosystem as you discussed. So David, turning to you, can you share about some trends that we're seeing in the blue carbon market and the voluntary carbon market?
Yeah, absolutely. So I would note that probably the key trend in relation to credits that are being generated from blue carbon projects is that demand is both consistent and growing. So blue carbon projects have been highly sought after for a long time, but really not solely just for their climate impact, but really the whole package of benefits that they create. So Emily discussed a lot of them. Many are really important to a lot of value chains, including kind of the improved coastal resiliency component and the direct benefits to the local biodiversity and local populations. I think this, coupled with the fact that blue carbon ecosystems are impacted by so many of today's supply chains, really creates a sense of demand and quite a lot of popularity for these ecosystems and seeing these ecosystems preserved and restored. And I think we're seeing this particularly from corporations who have value chains that, have elements, whether they're, related to the marine environment or the coastal environment, as well as resources that might be derived from these ecosystems.
And, I know that you've been out to our mangrove project in Indonesia, Emily, you as well, and a project we're assessing in the Philippines, as well as other sites. So I'm curious for you to share a bit more about what ClimeCo specifically is doing in the space of blue carbon.
Yeah, absolutely. So ClimeCo is a provider of environmental solutions and has been developing carbon offset projects since 2009. The organization has really prioritized creating high quality decarbonization projects. And in 2022, we developed our first blue carbon project, which is a mangrove reforestation project in Indonesia, specifically in the Aceh and North Sumatra regions of Indonesia. We're doing this in collaboration with a local partner there called Yakopi, who is really dedicated to embedding themselves with local communities and making sure that communities are highly involved in these kinds of projects. We are slated to complete the project this year, and we expect to have over 2,700 acres of native mangroves planted and have involved nearly 200 villages.
Yeah, I think the collaboration with the villages, across a large span of the coastline is really exciting to see that impact and the folks coming together. I'm sure there are some challenges with the coordination as well.
Yeah, I think Emily knows that by heart probably, but I would say both of us have been out there to the project, and I really have to give up to our local partners there who really, we've been there for the public consultation meetings that they've had with these villages, and I have to say, I think the amount of respect and sensitivity that they treat these public consultation meetings with in terms of kind of respecting the individual cultural norms of each village has been highly, highly impressive. And we've been out there both looking at, nurseries that have been built by local communities and tended to by local communities and brought out to these, essentially mudflats that are ready for mangrove reforestation, whether that be by foot or oftentimes by boat. It's been just an incredible and, really ambitious project. Emily, I just got the numbers in, I think updated numbers. And I think currently we have, over 800 members of local villages employed through this project. One of the elements of the project is also that gender equality component, which has been handled, I think, really spectacularly well in terms of kind of cultural sensitivity and cultural norms in the region. And I think the most updated figure in terms of how many mangroves have been planted is 1.4 million mangroves.
Wow. And are all those planted by hand?
Yeah, I think that's the most incredible bit is that every single one of those has been planted by somebody from a local village.
Yeah, and I guess I would also plug that ClimeCo made a video about the Yakopi project, and it's on our website. And David, you're a star on that video, but it's really compelling to see the work on the ground and the impacts of these projects.
Yeah, absolutely.
Well, I really appreciate both of you coming on to talk about kind of what is blue carbon, where are kind of the growth opportunities. I know we talked more about mangroves in terms of ClimeCo's activities. Would you guys like to share a little bit about, have we looked at other project activities like seagrass? Emily, some of the other activities you mentioned in terms of blue carbon ecosystems, and what do we think about those? Are they feasible? Are those types of projects on the market today?
It's such a great question. If you look at the landscape of blue carbon projects today, you will notice that most of them are pretty focused on mangroves. And I don't think that that's because mangroves are, somehow superior to the other project types, but I think it does represent some barriers to entry and some challenges for some of the other project types. I think that being said, some of those problems are starting to become addressed, and I think that we should expect that a lot more of these projects and the other project types, such as tidal marshes and seagrass restoration, should begin to take off. So I would note, like, for example, for some of these projects, the implementation side is really both complicated and expensive. So, for example, the tidal marsh projects tend to require some sort of a hydrological modification, which means that you're going to use a lot of heavy equipment and tons of coordination. There's also the element of, for example, for project types like seagrass, which happen really closer to the marine part of that ecosystem, you're going to come across a lot of complications in terms of dealing with who owns the carbon rights and the ability to be able to generate carbon credits from those, right? So seagrass beds typically are embedded in the ocean floor. And typically speaking, there's not a lot of owners that are either private or communally owned lands. Is typically owned by some sort of government. And we're already seeing some of those barriers beginning to be addressed. So I think in 2020, Virginia passed some enabling legislation to allow for projects such as seagrass projects to happen on their ocean floors, which is pretty incredible. And then lastly, I'd say some of these more novel blue carbon projects, like the ones that Emily had mentioned, are the science has really begun to pick up in the last several years, and we're seeing new methodologies being developed for those. So we should be able to see the eligibility for a lot of new project types come into fruition in the next few years.
Yeah, I think that question of ownership is a real challenge. Who owns that underwater system? Is it the federal government if you're talking about the US, or is it the state? And who can give those rights? Can it only be developed by the state? I think a lot of those challenges exist in that ocean area. So thanks for bringing that up.
Yeah, thanks, Erika.
Absolutely. And I really appreciate both your time today. I'm sure there'll be more comments about blue carbon and questions. So I expect to have another conversation about this, but I think more focused on the community benefits aspect and, what ClimeCo is doing and what project developers are doing in the community space to engage, local and indigenous folks about how they want their ecosystems and their lands and their waterways protected and restored, and what those priorities are. So I'm excited for that next conversation as well. So thank you both for joining.
Yeah, there's so much to say there. So I'm looking forward to that one as well. Thanks so much.
Thanks for having us.
Whether you're a seasoned ESG practitioner or embarking on your sustainability journey, ESG Decoded is your trusted source for inspiration and actionable insights for responsible business practices. Subscribe on your favorite streaming platforms to be notified of new episodes dropped bi-weekly on Tuesday mornings, and connect with us at ESG Decoded on social media or by visiting www.climeco.com.